one only boring slide right now. And then I promise you the rest will sound very interesting. Alright? Yes, the only boring slide, I promise. So this is how research follows in the space industry. So we've got objective-based policy, we do R&D, we do development and production, the contracts with the aerospace firms, and then create the space projects. As entrepreneurs here who are trying to get stuff on the ground, we're mainly focused here in the market adaptation space. We want to take technologies and inquiries and systems and commercialize the technology of space to the market, and then get our VC funding for private financing. Now, with Elon Musk, SpaceX, and the other space ventures coming up in the Virgin Galactic, that's pushing it more to here where the entrepreneur will sit. And this will slowly go on in the next decade. Last boring slide. So let's start with something about everything else. Everyone uses the Google Maps on your phone, right? And we all know that's GPS, right? Now GPS is part of what we call position, navigation, and timing systems in space. And for the whole of this conversation, I just refer to them as PNTs because they are this many PNTs networks. Alright? So this one is the Americans' GPS, Russian GLaNOS, Europeans Galileo, Chinese dual compass. Right? And India, Japan, and Pakistan are all making their own version. Now, the Japanese have a cool addition to their technology is that when you use GPS in tall buildings, the signal can get reflected off the tall buildings and put you somewhere else, like on the back of the street, like 100 meters or 200 meters away. The Japanese have solved that. Right? Now, the other two, Argos and SARSAT, actually are referring to two US systems. This is an image of the ocean movie network. Now, if you guys remember in the old movies where they put up a satellite tracker on the criminal and they go around, they were talking about Argos. So Argos can track your position and transmit via satellite where you are, back to base. So this is the old-fashioned how we track one. The new one says I put a GPS, so I'll get a GPS, but this one will still give me my data. For SARSAT stands for Search and Rescue Satellite. So that's your best friend when you're on an airplane. If the plane crashes or anything, it is this satellite network that finds you and sends Search and Rescue out to find you. Alright? So for GPS, it's only about 10 to 20 meters accuracy. But we're now planning technology to give us 1 meter accuracy. In the US, there's something called the land augmentation system, and we have EGNOS in Europe. Now, they give 1 meter accuracy, which is great for aircraft that want to land on runway. But what happens if you are trying to have a self-driving car? 1 meter is the difference between hitting the person on the street and staying on the road. Not necessarily really good. But with the new technologies and the new satellites coming out, we are talking about 1-2 centimeter level accuracy. So let's have a quick look. So what's in your iPhone? Your iPhone has GPS. What else? Does it see anything else? What else does it see?
It's got a bunch of other accelerometers.
Well, from from satellites. Wi-Fi is because it's correct. We have an assisted GPS chip that takes Wi-Fi and cell phone tower data for your position. From the satellites, we only have GPS and we also use the Russian GLaNOS system. You can check the iPhone 5 specs, it's highly rated, just don't announce it. Right? And in the future, we'll have European Galileo. And that means potentially 1 meter accuracy for your phones, or 1-2 centimeter accuracy for the new GPS units that you buy. Right? I just new services. So I gave the example of autonomous self-driving cars. 1 meter is between hitting a person on the street and staying on the road, but at 1-2 centimeter level accuracy, you can actually avoid getting hit by a car. Sorry, the car can avoid hitting people. Now, in farming, GPS is not accurate enough. So you think about it, there's a 20-meter error, you've just lost a lot of land in terms of when you want to plant your vegetables or other crop harvest crops. So they actually spend a lot of money toward their own land-based systems to augment GPS to that level that they need. With the new satellites, they don't have to buy those equipment anymore, and all that equipment probably is going to have to be replaced when it's end of life. So, aircraft maritime navigation systems. when GPS came out, there was a 37% savings for airlines in terms of fuel usage, and they also allowed you to put more airplanes in the sky because you were more accurately tracking their location. Right? So with the new system, the better the accuracy, more planes you can squeeze. Last one, geographically aware advertising. I think it's a businessman stream. Imagine you have a bus that goes to a school zone during school hours, and it will display all the ads for students. And then when the bus goes into the city after work at 5 p.m., it's for all the people after work. Targeted advertising. So I want you to have a consideration of what opportunities are available when just the idea of accuracy in terms of distance. Now, let's have a look at telecommunications. Satellites, the biggest market is telecommunications. And here's what we're looking. So if you want to launch a satellite space, there's a $6 billion market. Satellite manufacturing is $15.5 billion. Earth sector manufacturing, which is ground stations, on top of satellites, $5 billion. And communication satellite services, $125 billion. So this last one here is you making an overseas call. Go ahead.
What's satellite manufacturing?
So, somebody has to build the satellite. Alright? So that's satellite manufacturing. Okay?
What's Earth sector?
Someone still has to build the ground station and maintain it. Does that make sense? Cool. Alright. So there's two challenges when we talk about space telecommunication. Alright? First, we have a limited number of orbital slots. And I'll show you a quick diagram there that shows it. And the other is radio frequency spectrum allocation. We only have so much radio waves to play with, and it's heavily overused. And you get to see that. So, this is geosynchronous orbit. Geosynchronous orbit is a position where the satellite sits above the Earth, and as the Earth rotates, the satellite remains in orbit over the Earth in that same position. They're very useful for communication. You only need 3 satellites to cover the entire planet, and that makes it very valuable for videos. You want to watch your Oscars live, it's by satellite. You want to make a phone call, you know your phone line's going to work. And there's only so many slots available. Right? Now, the colored dots, now like example like this represents services. As each slot only has 1 satellite. Right? And there's only about approximately, I think it's 180 slots. I have to double check that available. Because each slot is about 1-2 degree separation. Right? And this big blank over here, that's the Pacific Ocean. Nobody's there.
Are they on a flat rate?
Yes. So you know, basically sits around the equator. Make sense?
But I mean, could you have a couple of satellites in the same slot that are not even close to each other because of the distance?
They might hit each other. So you have to really sit in this distance. You know?
Is that governed by law?
Yes. The International Telecoms Union owns this. So each satellite is given a box 50 by 50 by 50 kilometers to stay in. And that's actually quite a challenge in its own right.
Yeah. But is that how much is 1 degree of distance?
I haven't calculated that actually. But it's quite a feat to actually stay in that box.
What about the end of the light satellite? Is the satellite deorbit and then you have that slot?
Yeah, so what they do is they carry enough fuel to fire it out outside of the orbit, so it goes into a special orbit called the graveyard orbit, which means you're never going to worry about it anymore. It's rust and peace, but there was oxygen to rust. And that's what you do, and then the slot's available for the next person. Cool. So it's very heavily protected. Alright? The other one, your radio frequencies. This is how Australia allocates radio frequencies. Alright? To give you an idea of this, because I know most people, we don't expect you to read this chart, that's your Wi-Fi. 2.4 gigahertz, 802.11 G and G. And this is your new 802.11n or 802.11a. So those here and here are all you allocate to Wi-Fi. Now, the sad thing is that it's not used for satellites, it also fights with telephone, with just cell phones. We use the same frequency band for satellite communication as we do for base mobile phones. So we have this issue where we don't have enough bandwidth. So you can look at some of this here, for example, in this 3 bars. This same area is used for 3 different purposes. And we're trying very hard to manage it. And it's the law of physics. We can't squeeze anymore. So what have satellites gone to do? We've decided to switch to laser-based communications, or free space optics as we call it. So here's a satellite that was built to help test the idea. It's called the Artemis geosynchronous satellite. It was launched in 2001 and basically contains a laser link payload. So this is a semiconductor laser intersatellite link experiment, right? And what it does is fires a laser beam at 38,000 kilometers to the Earth's surface, and it maintains communication regardless of the weather condition, which is the main issue for laser communication, because you need line of sight or car goes in the way, the comms fail. Alright? So this satellite can actually do it. This is from 2001. And current new satellites going up are deploying this technology. What's great about it is you can now borrow this technology and apply it on Earth. So you can actually build infrastructure that does lots of communication at short distances. Because when I say short, the record for this distance is actually 24 million kilometers. And that belongs to the Messenger mission, which is a satellite that's gone off to see Mercury. Alright? Now, let's get to what... Go ahead.
In really bad weather, is there any degradation of the laser?
That was built to deal with that. Lasers normally do, but that laser was designed to deal with that in mind. So there's
no sort of, middle of a massive pads or whatever.
Well, there are conditions. There are going to be exceptional cases.
Yeah.
So they covered it in 50 different weather scenarios, which constitute 98 to 99% of all weather conditions, and that it worked. So the last 1%, you can alleviate that by making sure you put your satellite ground station somewhere that doesn't get that weather. Make sense?
Does the receiver in that case need line of sight to the satellite?
Yeah, both is a line of sight system. But if you have clouds over, it doesn't matter, it can cut through. And there's error correction and stuff.
So the tracking of the Earth station, it's tracking it, would have some sort of receiver would actually orbit.
Yeah, so the laser is always pointing back to the station.
Tracking satellite?
What do you mean?
The receiver on Earth, would have some sort of system that would actually pick up that laser.
Yeah, so basically, once the satellite's position in lasers is marked as linked, then they're able to transmit data for correction. And there's backup links as well. So this is something new that's coming to the space age. Alright? So, to remote sensing, the lovely Google Earth photos that we have. And let's talk about how useful. So let's talk about somewhere a little bit close to home. And close to home, this is Cyclone Yasi that when it went over Queensland. And as you can see, this massive thing, they just covered so much of the continent. Now, how the heck do you prioritize emergency services in a storm like this? Where do you send the people? Right? So we start off with this. So this is a radar cross-section of Hurricane Sandy before it hit New York. Green is a little bit of rain, yellow is moderate, red is heavy rain. So using this cross-sectional data, plus also with data from the wind radar satellites that give us wind speed, we're able to prioritize which sections of the hurricane actually require some people to go in first and save lives. Yep. Sure, go ahead.
I was just at the GSMA summit overseas, and they were talking about Haiti and stuff, just overlaying data.
Yeah.
And they did a big data research, but when that happens, it's where you send emergency services to. And they actually looked at cell phone data. And what they looked at is where do people go on weekends and so on. So they look retrospectively. And when a cyclone hits, you've got to sort of serve the people on the ground, but you've also got to go and make sure there's enough capacity to hold where people are going to run to.
That's right.
So they overlaid that data to predict. So it's not just where it's going to hit, but where people are going to run as well.
Yeah. That happened when the Japanese earthquake hit. 60% of the telephone towers remained standing. So they were able to use that to find people and locate and track them down. So things like that is also equally important part of search and rescue. pieces of this video is a compilation of all the photographs we took. And it shows Earth at night. Normally we see the globe in daylight, but I thought this would be something different. You can see all the lights around the cities and everything. So if we have a closer look, so let's look at the United States for a moment. You suddenly can see the marks of civilization. So if you're Star Trek flying through space and you want to detect whether there's alien race on the planet, you're looking for stuff like this. That's how you tell whether there's an alien civilization or not, or you have a lot of volcanoes. Right? Now, I'd like to show this particular photo. So down here, we have China. This is Japan over here. South Korea. North Korea. Alright? This is Pyongyang. Right? It just gives you an idea of how obvious we can capture space. And you'll find there's a very peculiar quality to this photo. Notice that these lights in the oceans are actually looked at like straight lines. You guys see that? Those are fishing boats sitting on the ocean borders of the country, waiting for their chance, waiting for their time to go in. So they are allocated, they're only allowed to fish certain times, so they're parked on the border waiting to go in. Alright? Now, let's go and look at Australia for a little bit. Can you guys see from over there? Cool. So we have Australia. So Brisbane, Sydney, Melbourne, Adelaide, Perth. What do you guys think is happening over here? Okay, I hear mine. Anyone else?
Aliens.
Yes, we have many things happening on Australia, as you can tell. Bushfires. These are days-long or week-long bushfires that are going on, and they're obviously space.
What's burning out there?
Yeah, scrub. So there's stuff burning. Now, this is just a snippet of what observation remote sensing sunlight is. So, for entrepreneurs, we would love to figure out what's available out there for ourselves, so we can build businesses around it. So there's a group called the Committee on Earth Observation Satellites that publishes data on all the civilian satellites that do remote sensing, as we call them. Alright? What is that? Set up in 1984, there's 52 member organizations that represents the countries. Now, there are more than 400 space missions in catalog, and over 100 of those space missions, the data is available to the public. You've got to do a little bit of digging, but you can get the information for free. So the kind of things you can do with this information is still pretty much in the unknown category, just because there's so much data. Right?
What kind of data do they record, Brian?
Everything I can think of. So, I mean, there's a case study I was reading that measures the amount of salt in the ocean water, salt salinity, and when it goes over land, it actually helps you find freshwater aquifers. You know, there's of course in the photos it always takes you to measure deforestation and such, forest fires, infrared images, and so on. So, like in city planning, they do thermal-scan images of cities because they can tell which sections are hot. So then they go, I need to go plant trees here, a park there would help alleviate the heat, things like that. And this is one of the oldest and probably the most famous. It's called the Landsat program. It was launched in 1972 under another name, but it was changed to Landsat later. And it's the longest running program that takes images of Earth. So it takes a picture of every section of the Earth every 16 days. And it's been doing so since 1972. Right? So there's millions of images of the Earth's surface over easily 30 year period, 40 year period. And for all of us who use Google Earth, when they built Google Earth at the start, they didn't have all the satellite images. They grabbed it from this database to design it first as a proof of concept. And it was this data that showed that Google Earth works. So there are satellite data that's available that you can commercialize. Now, it's also getting easier to get into the satellite space. NASA is now building satellites using smartphone components. The same stuff you find in your pocket. And as you can see here, it's only the size of a month. And they're testing this right now. Hopefully in the next 18 to 24 months, they will have working units and it will be a commercially viable option. For now, this remains an R&D project. Right? Anyone? All of you here are familiar with the idea of Kickstarter? So let's talk about a few Kickstarter projects then. So this is IQ. Basically, for 100 bucks in total funding, you can tweet from space. So there are people, so you actually can tweet from space. You have an onboard camera, you can request to take photos. So I backed this project myself. I was like, awesome, I can tweet from space. Now I just want to go to the aliens.
Okay, so all 2,711 backers will be able to
Tweet from space.
Oh, okay.
Okay. And then it will be sold as a service that's continuing on as well. Another project is called Liftport, like 100 grand funding for only 8,000. This is an R&D project to basically build a space elevator. A long ribbon that goes from the ground up to somewhere high in space, and you ride it like an elevator. Alright, so this is R&D. He will tell you straight away, and you watch the video, you can't build it on Earth yet, but he thinks he can build it on the moon. Alright? That's what he says. As we shall see. Alright? The last one is the Arduino satellite. Are you guys familiar with the Arduino boards? Alright, for those who are not familiar, Arduino boards are basically really cheap computers about the size of your mobile phone. You know? It's like $100 bucks, you plug a keyboard, a monitor, a mouse, and you can do stuff on it, and it can run Linux. Right? These guys have taken this little thing, the Arduinos, and have turned it into a satellite. So what has effectively happened is that if you can run Linux on this, you can then write all the applications you guys have been writing in Java, in C++, Java, you can run on this thing. You already would have, for the programmers, you can code for satellites. Now, if you can run Android on it, which is a flavor of Linux, there are compilers that will convert JavaScript, HTML, and CSS, the stuff you write web pages in, into command code for Android, which will therefore run satellites. So potentially, you could be running a satellite of HTML or a text file. One of the concerns that we deal with in space, that's a big one, is orbital debris. You know? So here we have a photo of solar panels from the Hubble Space Telescope, and you can see it's damaged by a small piece of debris. Right? Now, we can't track everything. We only can track the baseball, which is about 10 centimeters, 22,000 objects. The marble size one is about 500,000 of them out there. The 1 millimeter pieces, dots are larger, it's 100 million pieces. Now, why do we care about the dot? It's because that little dot at that speed, it's traveling at like 20 times the speed of sound, can puncture a hole in the spacesuit. And that can kill the astronaut. That's one of the fears. And what has happened is that something that size has actually caused a crash on one of the NASA shuttles on re-entry, I believe. So these are actual dangers and concerns to be worried about. Right?
That's from all satellites?
Yeah, so whenever wrong it launches, stuff gets left out there, satellites get damaged, parts get dropped off. You know? So to give you an idea of how it is, here's a constellation of satellites, very well known called Iridium. There's about 36 of them. Now, here we have Iridium 33, going to happen nicely, and then we have an abandoned Russian satellite over there, Cosmos 2251, and they actually collide. And the red dots represents all particles, the debris, and the mess they create.
This happened?
Yes, this has happened. Alright? So, that's it. Now, what happens is you try to avoid it, you know, and avoid it at this distance. So you can see as it goes around, it forms like, it goes across the equator like a belt. So everybody who crosses the equator has to worry about that. And now it's like two straight lines, two belts. And so therefore, any orbit of any satellite that crosses it will be an issue. And you don't get how bad it is until you see how much stuff there is in here. And that's how much stuff. What's up?
Question. Is that a simulation or is that being
That's simulated. So every piece of space basically that we can track, we've mathematically calculated out its path. And that's what you see.
So those are all baseballs?
Yeah. All the baseballs. Makes sense? So if we look at how much stuff there is, here's a graph that shows you the amount of stuff. So happening in space. So remember here,
Is that time?
this is time, objects, and this is how much is going up. This is number of objects, 5,000, 10,000, 1,000. As you can see here, this is the Apollo era. So it flattens out a little bit because it's been for one shuttle accidents, and it continues rising again.
One? It goes out.
No, it just people stop programs. Right? The main concern here is these two jobs. So the first one is the satellite crash I just showed you. Right? The second one on top of it is China firing a weapon at one of their own satellites. So the anti-satellite weapons testing that China did. So we're very close to the point where we have so much rubbish out there that we cannot actually send stuff to space safely. And we're very concerned that when that happens, we're screwed. Right?
So, is there any solution about it now?
Everybody's working on it in different ways, but nobody has come up with something that's really viable at this point. You see, to deorbit a big satellite, you can make another satellite go pick it up. That's also bad. But how do you pick up 100 million grains of salt? Exactly. That's the challenge.
Critical mass that gets reached, and then everything starts exploding, and it goes.
Yeah, that's the Kepler syndrome, right?
Yeah, and then it won't like that, it'll just be a massive yellow. And you won't even be able to launch a human through it or a spacecraft through it alone. Yeah.
Definitely, yeah, you're right on that one. So that's the Kepler syndrome. They say basically there's rubbish, when it hits more rubbish, it will break into smaller parts. And to the point it's so dense, you can't send anything out of safely. Some say it's happening real soon, some say it's going to happen right within the decade. There's no actual number that's going to put down. So,
So like a decade?
no, yeah, most optimistic. And
You know, it's like a mission to Mars. I'm not going to come back in 12 years' time.
In the last week, there's been another spacecraft hit.
Yeah, this is they hit a Russian one,
Russian one, so that spike just went up again.
Yeah.
Critical mass will come very quickly as they build up.
Yeah. No, I think some guy says it would happen in a year or two. Yeah. I think Joe Pelton was telling me it would happen in like potentially in 18 months.
So, I mean, that's really, really serious stuff.
Yeah, that's actually
what happens if like no GPS is no...
Well, okay, the GPS will still be up there for now. But what will happen is when you need to replace the GPS satellites, what's going to happen then? Because you can't send stuff up to replace it when it's on service. You know, so eventually, if assuming rubbish, this thing happens, all the satellites will still be, most of the satellites remain operational, but eventually wear and tear will kill them. You know, and they'll be out of orbit, they run out of fuel, whatever reason, and we can't use that anymore. And we're going to lose these satellite services. So it's almost a slow death if we don't pick it up kind of scenario.
Well, the GPS satellites could get blown up as well.
Yeah, that's the sad part. I did want to
As long
mention
as
it.
this stuff keeps working, once critical mass is reached, it's just...
But most of the debris at 800. The GPS satellites are 830 kilometers, correct?
Yeah, but then what's getting blown up where
Yeah.
it's not just rows and things like that. And on top of that, a lot of the spacecraft actually are left over with fuel in their tanks and pressurized gases, and after 10, 20 years, the tank cracks and blows up, so the spacecraft blows up anyway.
That's sad.
There's a lot of problems that we have to face in deorbiting this stuff.
Yeah, that's so true. And it's a challenge we all have to work on. Yeah.
Are there any techniques that are working?
Well, we're all working on it. We don't have one that has been
Has
answered.
anyone got one little bit?
Look, short answer, we currently deorbit satellites when we can, but we can't clean up grains of salt just yet. That's the short answer. Right? We're working hard. Everybody is.
Is there anything to penalize people who...
Well, if you penalize, who should enforce? You know, so that's one of the things. All the space law is by treaties, so nobody has enforcement power over another. Pretty much. It's never anyway. when we first went up, we didn't know that we were doing this. And by the time we found out, it was too late. You know? It takes decades to rebuild the space, any piece of aircraft, spacecraft. So even if we do it, it would be a decade, 2 decades, 3 decades before we could actually build spacecraft that do less damage. You know what I'm saying?
Why are you saying the space regulation? Regulation.
Yes, that's definitely something that's on there. A lot of people are talking about. Right. So moving on, let's talk about spacecraft. So let's talk a little bit about a company called SpaceX, a local entrepreneur. So Elon Musk started this in 2002. He spent $500 million to get the company on the ground. He in 2012 won the contract to supply the International Space Station with goods and services, with supplies. And it was a $1 billion expenses over 10 years. That means $100 million a year. Now, this is really low in contrast to the fact he had about 20, 30 launches, I believe. I just checked the guide. And to launch the NASA Space Shuttle, anyone guess how much it costs to launch it? $1.5 billion for each launch. It was $300 million when they first built it, but now it's $1.5 billion. Okay.
I had one of the original handbooks for STS-1, which was this thick. And now, by the end, it was this thick for the same launch category.
Because of the two shuttle accidents.
Yeah.
So unfortunately, it's now 1.5 billion launched. But even at 300 million, this is a hell lot cheaper. So a lot of people like this, and it also means we're getting debt. Now, one of the little known facts is that when Elon Musk first started trying to do this, a lot of people didn't understand what he was doing. So he did like any good entrepreneur, says, let me bring my product and show it to you, and then you can work it out with me and show it to you, right? So he parked his rocket outside the Washington office of the FAA in the US. Yeah, this is the cool thing. He could do this because he had designed his rockets to be roadworthy. They could actually fit on a road. Put on the other truck and sit down. So he parked it in front of him. Now, his factory is in California. His launch site is in Texas. So he took this thing from California, had it driven all the way to Washington, D.C., parked it outside the office, and then went, come and have a look. So I think he got his approval after this for some reason. I suspect that. Right? Well, if you're going to build anything, you want to know it's safe, it won't blow up, not going to hurt anybody, that kind of thing, you know? So the FAA had to make sure that all those regulations were met.
Hey Brian, how did he make that in 1 year? It says 2003.
Sorry?
How did he make it in 1 year?
1 year?
You said it was started in 2002, right?
Well, see, his rocket, he has gone through 4 or 5 iterations of rockets. So this is his first one. When it was first...
It's pretty quick.
Yeah. So look, he had a lot of R&D and he had a good team behind him. So this was, they had the first one out to start the testing. And they needed one to show the FAA. So this is not the one he's sending stuff out with now, but this is one of his earlier babies.
That's just an episode. Yeah, that's it.
If he said with you, I would be very worried. Yeah. So as you can see, we work hard to get things done. So this is Falcon 9 on its launch to the International Space Station. And this is the Dragon capsule that's finally docking with the International Space Station. Right? And that was the payload that was sitting on the Falcon 9 rocket. And that was the very moment that the first commercial entity in the world, it was docking with the International Space Station. And NASA went, yep, you can put the supplies and parts in. Right? To give you a bit of idea of size, right now, Americans use the Soyuz rocket from Russia, send people up, and that sits only 3 people. The Dragon capsule sits 6. So it's twice the size already. Okay. Now, everyone talks about space tourism because there's a lot. Only a handful of people, rich people there go. And you always hear of those who stay at the International Space Station, right? Those are the current space tourists. And that comes from a company called Space Adventures. Right? Each ticket is $35 million a piece. Alright? And then what they do is been selling excess capacity on the International Space Station. Right? And they launched from Russia. They work with the Russian Space Agency. very much like this. So you can see this tiny little person standing there next to this massive rocket, and it's only sent 3 people to space, and a few parts. Now, when a lot of people, everyone talks about the NASA shuttle, oh, it's all hydrogen and oxygen. This thing's running off kerosene. And apparently, kerosene is actually a better launch for launching at lower orbits, so at lower atmospheres than hydrogen and oxygen. So they use this kerosene instead. And this thing is ridiculously reliable. This thing has been launched in blizzards. They'll take off. The NASA shuttle, if it rains within a 50-kilometer radius, they have to scrub the launch. It's a ridiculous comparison, but it is the case. And this is the same one that sent Yuri Gagarin to space, effectively. And Yuri Gagarin is the first man in space. And of course, we all know about Richard Branson's Virgin Galactic. This is his What 92 in space ship too. So the idea of it is very simple. It's a plane that flies as high as possible, detaches the middle craft, the rocket engine on the back, and it fires you off to space. Right? And this one won the $10 million prize from the X Prize Foundation. It was built by a company called Scale Composites Design. Now, Richard Branson has sold about 500 of these tickets, and each ticket was $200. Alright? So he's collected $100 million without even providing any service up front. So I think as any entrepreneur, you can respect how lucky he is. Right?
But how long do they get to spend in space?
Pardon?
How long do they get to spend in space?
Good question. Once you go up, so let's say your spend in space is the feeling of zero gravity, right? 6 minutes. Yeah, it's 6 minutes. It's a joyride. So, 200 grand for a roller coaster ticket for 6 minutes. Yeah, you're right. So he passes the 100-kilometer mark, which is technically usually space. It's a free fall. You feel 0 G or microgravity for 6 minutes, and then it comes up. Reality hits. While the guys who go up to the International Space Station can be there for 2 weeks. All right. So it sounds like 200 grand, 25 million. It sounds about even. Yeah. So if we look at it, the countries doing all space tourism, aside from Russia, is America. So what does the FAA say? All right. So first, they went to look at all the different launch sites in America. So there's a quick listing here for your reference. So it's not just 1, 2, or 3 points. There's like here, it's about 10 to 12. And there's about another 12 across the globe. Really?
These are all private businesses?
No, so these are mixed between private, military, commercial. Alright? And this is what FAA is currently researching. So these are all the components. So when we talk about Falcon X, it's more towards the orbital stuff. Virgin Galactic is suborbital. Alright? And they're both trying to build spaceport operations. But they also got to look at the health of the individual. So that's aerospace physics and medicine. Look at how to train personnel, how you stay in space, what's the human safety ratings, and all the other things that make it work. I mean, how would you even regulate space flight as a tourism? You know, these are questions that nobody has done it before. Right? So, what about Australia? Where does Australia sit with this? So we have a National Space Policy Unit, the SPU, and they came up with this piece of data. So what is Australia focusing on? So these are the things in the space industry that we use here in Australia. And the things, some of it might be very obvious to you, but the one that's least obvious to people outside the space industry is time stamping of financial transactions. So what happens is that your phone is there's 4 atomic clocks on each GPS that averages out, that gives you your time. And it gets its time from 50 GPSs, so 50 atomic clocks in the US that updates it every 24 hours. So your timing is, if I recall correctly, is 100 billion for a second accuracy, average. So time stamping of financial transaction has proven to be very useful for that. It's also been great for power grids to reduce the amount of damage and on the infrastructure as well. Alright? Now I don't want to talk too much about this because there's a new one due out somewhere very soon, if they ever release it. You know, they said it would due out due out like January, February, March, and March is here. Like, where is it? Alright, where is it coming? So to Australia, what does this mean financially? It's a $12.6 billion increase in GDP about max and max by 2030. So there's that much money floating around in the industry. We're talking here about safer space flights and safer seaways, because we can put more aircraft in the same space and better track them. Right? More efficient transport networks. Any one of you who've ever worked in a logistics company knows how tough it is to track your packages. This will help. Right? And enhanced capabilities for measuring the impact of climate change. So there's a group in Australia that has built a ground-based laser that you put next to a coal power plant, and it fires the laser into space. And it measures the amount of particles that cross the laser beam, and it will tell you how much carbon dioxide is in the atmosphere and how much it's producing. So it's a very accurate, so it's a good way of being able to track a large amount of carbon dioxide being generated or being removed from the atmosphere. Alright? So let's just move on to some of the cooler projects that we see. Lunar Unpacked. So Google has a $30 million prize to put a robotic probe on the moon. And the beer will definitely flow to the moon. So the idea here is a four-legged Australian marsupial powered by Linux will be running around the lunar surface. Completely open source technology. So that means you can, once it's finished, pull out the design specs and build it yourself. I don't know whether it'll be a great high-spec project, but I'm hoping so. Build your own lunar rover, literally. And that makes sense because right now, if you go down the road to the Powerhouse Museum, they have a Mars exploration exhibition. Alright? And they allow students to create hands-on these projects on a simulated Martian surface. You know? That's great for the students. We also have the University of Queensland leading an international initiative to build scramjet engines. These are special engines designed to go up to 8 times or 14 times the speed of sound. And they have, it's $14 million, it's a $14 million project. Now, they expect this project to be finished in about 20 years. So that means they need this technology to be available at the 20-year mark for the Australian space industry. Now, laser tracking of space, most debris is tracked by radar, but we need more accurate information of it. So we're now firing lasers to track it. Alright? And no, this is not the Death Star laser. Alright? Because what has happened here is that they eventually want to raise the power level of the laser sufficiently to be able to use the ions of the laser to push orbital debris. I don't think we're not going to be at the point to vaporize it anytime soon, but we can push it out of the way of satellites. That would be great. Right? So what can we do? We know there's, as I've shown you, there's a lot of opportunities in the space industry. A lot of things can be said and done. Right? You have to see for yourself in your own respective businesses how it can help. Would more accurate timing help? Would more accuracy help? Things like that. You know? If you don't know, I recommend you get training. Alright? And this is where I went. I went to the International Space University. Alright? It's interdisciplinary, intercultural, and international. So you can actually, when you go to this university and come out, you can sit down in any space conversation and actually don't get lost. You may not know the depth, but you know the breadth. So take your current expertise plus this course, and you can start having a look at seriously working in the space industry. Right? 2,500 alumni in 100 countries, great network, sincerely. And for those of you who know, all of you who know who is Arthur Clarke, he was the first chancellor of the university. A bit of trivia knowledge. He basically invented most of the stuff that we enjoy today, in terms of theory and design. So, this is I like to show off this photo. These are the people who are teaching me at the Space University at ISU. This is Scott Midry. When there's a natural disaster and the Red Cross has to go in, he gets a phone call from the Red Cross to process their satellite data so they can go in and help. This is Mark over here, the red shirt. Mark used to run an ISP in New Zealand, and he did the tech support for our course. It's quite crazy to think that you need someone who actually knows how to run an ISP to actually help run a classroom with IT requirements. So that's what it was. This is Song Yang-yi, first female Korean astronaut. She was with us for 2 weeks. Awesome lady. You know, she had a PhD, and then she went on to an American Idol version in South Korea to become an astronaut. So they started out with 35,000 people, and at the end of it, they had a live telecast at the end of the year, and she was one of 2 individuals selected. And after the show, she was selected to go on to the International Space Station and become an astronaut. You know, Sarah Langston, sorry. Sarah is a friend of mine now. She's at the University of Sydney. She's a really good space lawyer. When we wrote our section on space law and policy for our assignment, we handed her, here you go. What we got back, I think, resembled good powder, how finely she shredded it. Right? The last person here is, his name is Joe Halpern. He's written about 50 textbooks in the space telecommunication area. He's a Pulitzer Prize nominee, and he's the former dean of the university. And he comes here to be treated like a normal human being. And the reason why I say that is that when he goes for the international space conferences, he's treated a little bit like a superstar. He's one of those people. Right? You know, so all these people here have given their time freely. There was about 30 students to about 60 lecturers, including these guys, and they just volunteered to be here. And I can talk to you about every one of the 61 of them and how awesome they were and why they came. They came from all over the world. You got people from Brazil, San Francisco, Washington, all giving us talks and recipes. So, to quickly end this, I would like to show you a picture of Earth. This is taken from the Voyager spacecraft, the first human spacecraft to leave the solar system. They turned this camera around for the last time, and they took a picture of Earth. Now, this doesn't look like Earth. What this big planet you see here is Saturn in its rings. But if you look carefully, and most likely you can't, Earth is over there. It's a tiny dot on the screen. It's probably 1 pixel on this thing. Alright? It's just to show you how vast of a future we have ahead of us in the space industry. Cool. Any questions?
What did you learn at the international space?
Pardon?
What did you learn about it?
What did I learn at the International Space University?
How many years ago?
Okay, so I did the beginner's course, which is just like an orientation. That was 5 weeks, it's a 5-week to 10-week version. And I finished that, and I'm right now discussing regarding doing the master's program, MBA program at the Space University. Alright? But in that 5 weeks, you have crammed most like a year and a half of material. So you start with rocket science here, space policy and law, and life sciences here, right? Everything inside. So we were hammered in our brains. I saw more mathematical formulas than I want to count, and at the same time, in an hour later, I had to go learn about the 6 international space treaties. You know? So that's a lot of, it was a lot of work. 5 weeks, 10 weeks, short course, gets the ball rolling, because that's more about converting you to the space industry. Then the other courses are for more serious stuff. Be in the space industry or bigger projects. Anything else?
There's any universities in Sydney that have projects aimed at being part of what's going on?
Yes, so a lot of universities have projects going on.
And specifically,
UTS, unfortunately, I do not know of any. UNSW is considered our resident expert in space line. University of Queensland is scramjet engines. ANU has the facility for satellite testing, like radiation hardened satellite testing. And there's a whole bunch of other places. There's actually a couple of 30, 40 universities that actually do space related. I believe I have to check. It should be under this engineering department, but I have to check.
Out of all the satellites that we have up, how many are focused on the Earth and how many are focused?
90% are focused on sports. I don't have the exact number, but I know about 90% are focused on Earth.
Somebody wants to get involved with some kind of space entrepreneurship. What are some of the first steps?
First steps. Well, alright. So, this is part of my challenge I face is that I was lucky. I found a private the International Space University that lets me enter the space industry. I don't have that luxury. That luxury is not open to everybody. But there's a lot of places who are willing to take people on board. So for example, there's a company called USAT based in Adelaide that provides satellite-based telecommunication services. And they're looking for sales engineers. Now, not everyone knows satellite stuff well, but if you know really good Wi-Fi stuff, like calculate all the Wi-Fi and everything, you actually know about 80% of the knowledge required for that role. You just need to know the satellite component. Alright? So there are places you can find jobs in workplaces. So if you talk to the existing space companies, there are job openings that allow you to get in there. Places like International Space University or university courses that teach space-related stuff are entries. I myself am working on locating these open source projects, like the Adreno satellites, so you can actually start building your own satellites, develop training programs, whatever it may take, you know. So that's part of the process that has to happen. So it's right now early days. There's not many avenues, but I can assure you there are many people working hard on making more avenues for everybody. Anything else?
So you haven't invested in money in space ventures or anything?
Well, I Kickstarter. $100 for that one. You have to be very careful with space projects. They're rare, they come far in between, and most you hear will fail. It is as bad as the startup scene. It is like a you know, do you remember the Apollo mission? Do you remember how many rockets blew up before it actually got to space? Yeah, what's up?
You know, you see like footage of scientists like space station with their research. Tell us about what they're actually doing up there. And I mean, I imagine a lot of them going to biometric research.
What do you call it? Well, the space station only goes like okay. So the International Space Station only can hold only up to 6 astronauts. There's no point there. No, people in space single-digit numbers most of the time. Look, they do every kind of research on there. They have a micro furnace to build to metal testing. They do medical stuff, as you mentioned. There's a piece of research that came out of it about a treatment for cancer. So they developed in space a delivery mechanism for treating cancer. But the issue with that is that the process can only be manufactured in microgravity. So you can't actually make it alone, but the technology is there. So it's one of those things where we need a space factory. Okay? Does that answer the question?
So is that the main reason why they send the experiments up there? Is because microgravity?
Yeah, there's an environment that we're not familiar with. So there's always the radiation, the objects in space, you know, how do you survive in a harsh environment like that, plus microgravity. These are valuable things. We have to be where those things are to do the testing needed. Make sense? Anything else?
Yeah, I mean, isn't it worse than the startups because of the heavy infrastructure costs? Like, and from a pure price, you look at tech in the last 10 years compared to life sciences and some of the other long lead time, higher infrastructure costs. Part of the reason why technology is so rapidly outplayed everything else.
Yeah.
Isn't the physical aspect of space this enormous pain in the ass? There needs to be something like cloud to get over, or you think it can be implemented?
It will probably be, okay, so I didn't show the slide, but Elon Musk is basically building a reusable rocket. And what he will tell you is that the fuel cost is 0.03% for launch. The rest is vehicle. So you can create a reusable vehicle. The cost of space drops down by 1,000-fold easily. Alright, and that's a very conservative number.
And what does that put as a base cost for the return?
Put it this way, right now he's launching some rockets to space for under $10 million, $10 million, versus a shuttle $1.5 billion launch. No? So once he perfected the reusable rocket and the other projects are going on out there, you can get really cheap. So the cheapest cost to launch a satellite that I've ever seen is $8,000.
$8,000?
Yes.
So they're recovering space expenses.
Yes. So $8,000, just to answer your question.
Now we're talking startups.
It's not I know. Look, this is happening now, and we're getting there. So $8,000 is the company will send you the DIY satellite to build your own satellite, and if you pay $8,000 in full, you are also on the launch manifest, so you can go up. $8,000. Satellite plus launch. Well, they actually are smart on that one. So you only go up to about 300 kilometers up. The space station is at 400 kilometers, so you actually come back to Earth pretty fast, just because of air friction. Sure.
Is SpaceX operating at a loss right now, or are they?
No, profitable. They've been profitable for the last 5-6 years. No, sorry, since 2008, so it's 5 years.
Not over $500 million to start a company like that.
That's the thing. This is probably going to be the last era of such high cost setups. Elon Musk is working hard to make it really cheap. And so probably 1 or 2 more generation of companies. And then we'll have, basically the target is by 2030, 2040, a trip to space at the same price as going to New York on a commercial airline. That's how cheap we're after.
Were they too much worried about that?
If we're working to clean it up, then no. So cross our fingers that we figure it out.
So that's your startup.
Yeah. Space debris is going to be a big business. The trash collector always makes a lot of money.
Right.
Yeah, go ahead. There's a whole, I can tell from that is easily 200 space companies. There are 2 companies that are trying to move that like space. Are you talking about those?
No.
Yeah. Last question.
So, say you have an idea
Yeah.
of something you want to do, or you want to see done that week. Is there like are there like people you can sell this to, or like someone that you could, or do you have to go and like learn everything and then like build your own company? Can you like present to NASA and they have to submit experiments that can go out, or is it basically you gotta like find for yourself or like mechanisms for getting your idea out into space, or
So SpaceX doing what it's doing is part of the COX program, the commercial operator, basically a NASA program to create commercial companies that can launch stuff to space. So we got $200 million for that. So that's the first case. For us in Australia, we do have something called the Australian Space Research Grant. That was $40 million over the last 3 years to help start space companies, keep the space industry going. I would have to honestly say that for most of us, we're going to be in the second category where we're on our own.
yeah.
And that's something that we all have to work together to build up and be taken seriously before we can be in the space industry. That's all stuff. Guys, so thank you very much for coming. Okay. There's and the corner there, that beers for us, it's all free, please help yourself. So please pick up.